Hi all, welcome back to Cracking the FAANG interviews. Today I'm going to be solving a problem which has become popular in interviews. It's a very application based problem called edit distance. Before I dive deep into the problem, I just want to share a little context on edit distance. Edit distance is typically used to measure errors made in transcription. For example, if you were to scan a piece of text and the picture you took has text called a man, and when you scan this, your system transcribes it to amen. Um, how do we quantify this error? The way we typically do that is this metric called edit distance. What this means is the way you'd calculate edit distance here would be your system has missed a space, so this makes the edit distance 1, and then it has gotten a transcription wrong for one character, so it would make the edit distance 2. So the concept of edit distance is it helps you figure out how much error you have introduced in a text with respect to a reference text, and helps you measure the performance of your system. Again, this question has become popular, and I've seen it getting asked at Microsoft, Google, and Amazon, also Salesforce recently. So let's look at the problem with an example. I have a snippet here from Geeks4Geeks, and I'm also going to add a link in the description to the original problem so you can take a look at it. So what the question is asking us to do is measure the edit distance between two strings. We looked at the previous example, and the types of discrepancies or deltas that we care about is adding a character, deleting a character, and also changing a character. So you could add a character, AA becomes AAB. You could delete a character, AA becomes A, and you could change a character, AA becomes AB, for example. So let's pick one of these examples and try to solve it in more detail. So if string 1 is geeks and string 2 is geek, as you can see, there's a character deleted, so the distance is 1. But if I give you same strings, geeks and geeks, the edit distance is 0. If I change a character A in place of E, the edit distance is 1. If I change two characters here, the edit distance is 2. So I want to emphasize on how you would think about solving this kind of a problem. So the way you solve it is the input here is two strings, S1 and S2. And let's look at, let me break this down for you a little more. So you'd have two strings as input, S1, S2. And I'll take an example from our previous slide, geeks and geek, for example. So you have these two strings given to you as input. And the first thing that comes to my mind is we're doing a character to character comparison to figure out if the edit distance is 1, right? That is what the question is asking us to do, and for that we'll need two pointers. And what we do is we take this pointer I for string 1 and pointer j for string 2 and sequentially go through both the strings. So we'd have I and j at index 0, 1, 2, 3. And what we'd realize is once the pointer j falls off the cliff, we still have one value remaining in the I pointer and the edit distance would become 1. So if we follow this algorithm, we'd be able to solve this in O of m plus n time, where I'm assuming m is the length of string 1 and n is the length of string 2. And this is a linear algorithm, which is the best case given the amount of work we have to do. So this is the idea. This is how we'll be solving this question. And now I'm going to dive deep into code and walk you through. Again, I have a snippet here from Geeks, and I also have a link in the description. The first thing, as we discussed earlier, that I do is I take the length of both the strings, m and n, store it, and if the difference in length is greater than 1, that clearly tells you. So if we have two strings, geeks and geeks my, this clearly tells you the edit distance is going to be greater than 1, and you can return false right there. If that's not the case, we keep going, we increment our edit distance, we initialize our edit distance count to 0. We set both of our pointers I and j, as we discussed, to index 0, and we loop through them. And the while loop would say, while both the strings have not finished, you keep going. The first thing we do is we check if the characters are not equal, and if they are not equal, which is not this case, but if they are not, and if the count is 1, meaning there's already been a mismatch, we simply return false. It means the it means the contribution of count or edit distance coming from the previous step is 1. You're going to add 1 to it, which becomes 2. We don't bother incrementing it. We just simply return false. If not, as a thumb rule, what we do is we always increment the pointer from either of the strings which is bigger. In this case, m is bigger, so if m greater than n, we'd move the pointer I here. The reason we do that is the bigger string will have extra characters. Essentially. So if m is bigger, you know there's more potential for m to have extra characters. Given it has bigger length, it may have repeats or different characters altogether. So we increment I plus 1, so we move I plus 1. If not, if it's the other case, we increment the j pointer. If both of them are equal length, we simply increment both of them. And now, given we've come to this case where they are not equal, right? So all of this code is for when the pointers are not equal, we increment the count by 1. And if both of the characters are equal, meaning g and g are equal, e and e are equal, we just keep incrementing both the counters. So that is all that we do in the while loop. We are essentially going through both the strings together, and we are giving preference to the bigger string as it has more characters. And once we are out of the while loop, if we could let's see when we could jump out of the while loop. We could jump out of the while loop when both the strings have equal length and the edit distance is 0, or if one string is bigger than the other string, we'd iterate through both these strings, but we'd still have these extra characters, right? Like in this example, we'll go through geeks in both strings, but m and y would not have been seen yet because we have this AND condition here. In that case, we just increment the count by 1, and what that does is it's gonna add to the edit distance. The other thing you could do is also increment the edit distance by the number of indexes remaining, or number of elements in simple terms remaining, and you just return if count equals 1, which means is edit distance 1, as the question asks us to do. And as I said, the runtime of this approach with this while loop is going to be going through both of the string. The amount of work you're doing is going through both of the string, and it's going to be O of m plus n. Thank you for watching this video from Cracking the FAANG Interviews, and I hope you liked it. Please like, share, and subscribe.